Welcome back to this tutorial. This is part number 4, the last of this series. Last time we learned how to model the top and the bottom of the sole, but let me go back for a while, just for a quick recap. I activate quad snap, we take line command, and we pick the quad points of the bottom curve. That way we can trace the central line, which is exactly the same as the original one. If we switch to the top view, we can check and we see that these two curves are exactly the same. We're going to use this curve for splitting the bottom blue curve. Take the split command, select the curve, confirm with enter, then select the cutting objects, in this case the line. As you can see, now we have two curves. We can delete the line because we don't need it anymore. Now we can create a surface by using surface from 2, 3 or 4 edge curves as shown in the previous part of this tutorial. As you can see, we get a linear surface. We can change the color of this surface. In this case, we can pick red color. And we're going to create a new surface using Loft command. Select the first curve, but not the surface edge, the second curve, and enter. As you can see, Loft surface and the curve from 2, 3, 4 edges are almost the same. In this case, probably they are exactly the same. It's the same. You can select one of those surfaces and, for instance, the red one, and now we can delete it. This surface is developable. Set explode no, and as you can see, we can get a flat version of this surface, which will be necessary for the next operations, but we'll talk about it later. We can change the color of the flattened surface. Select both surfaces and move this a little bit far from the origin, in my case along y-axis. Show the layer where 2D curves are. Select a different color for this layer, so it will be easier to understand which is which. Select this curve, drag the gumball by the red point. We got a straight surface, an extrusion surface. In my case, if you go here under display settings, I turn on color backface and I choose orange color for this surface. Anyway, if you want to switch directions, you go to Analyze, Direction, click on the surface and enter to confirm. And now green face is the top face and orange is the back, as it usually should be. Go to the top view. As you can see, we are in wireframe view. Go to Project Curves command, default settings. Click on the curve, enter to confirm, then click on the surface, enter to confirm. That way we projected the curve onto the surface. If you keep this curve, this new curve selected, you can use it to trim the green surface. As you can see, everything looks pretty. I got a very similar surface to the first one I create with Loft 2, 3, 4 edges. As you can see, this surface is way simpler than the previous one. I usually prefer to use extrusion instead of loft or edge surface because it's easier to work with that kind of surface. Unrolled developable surface, of course, will work also in this case, and this is why, for brevity, I create top and bottom surface with extrusion. Okay, so we can go on. Assign paint material also to top and bottom surface. Sometimes we have to remember to save. Switch to shaded view. Go to surface flattening, unroll developable surface. Select the bottom surface, confirm with enter, and we get the flat version of the bottom surface. We can rotate it to align it to the 3D object. As you can see, this surface is flipped surface. If I mirror it with copy no, I can flip it and I can get the rightly oriented surface. Okay, now we have both 3D bottom surface and a flattened surface of that one. I show a picture that previously I've imported in RHINO, and I traced this picture, as you can see, which represents a human foot. There are several ways to measure the size of a foot. So let's use just this simple one, foot length and foot width, which are the maximum length and the maximum width of the foot, as shown in this picture. Then take a look at this chart. Since we are designing a women shoe last, we can start with size number 37, European size. So this line must be that length. In our case, we have something around 105 millimeters. So we have to scale it. I create a new layer. We call it flatten. We can move our flattened surface to that layer. So we select it, then right click on the flatten layer and click on change object layer. We can hide the SHOELAST layer for now. As you can see, we have to fit somehow the virtual foot to our sole. We can lock the flatten layer. Then we can select all curves here, and we resize our object to fit the sole. If you use Gumball and hold Shift button, you can do 2D uniform scale. Adjust the object until they match properly. Then show last layer, analyze direction of the flattened surface. White arrows are going up. In this case, they are going down, so we have to change one of those surface direction. We can flip these arrows down. Then, flow along surface command, click on curve, then click to the base surface, click to the target surface, and you'll get the foot shape projected onto the sole. That way we can understand if this shoe last is compatible with the shape of our reference foot. I'm going to analyze the length of this line, which is less than 100 millimeters in my case. I select everything, take scale 3D, press enter, choose a base point, in this case, for instance, this point, then type the measure you want to get, 230 millimeters. As you can see here, size 37 is 230 millimeters divided by this value. That way I have scaled our shoe last to the right size. Now this shoe last is EU 37. Let's do the final check. Everything looks fine. That's all. Thank you for watching. Bye bye.